Okay, so the goal of this video is to look at polar circles and be able to graph what a polar circle is, again, without technology, without a graphing calculator or Desmos. And really, a polar circle can really be thought of as two of the cases can be thought of as like a polar rose with just one petal. Then there's also just a very basic function that we looked at on the first day of polars, and that's like r equals a constant. So one circle equation we've already seen, this one right here. So this would be centered at the pole, centered at the origin or the pole, with a radius equal to a, with radius a. And so, if we just said like r equals 5, you'd have a circle centered at the pole, radius of 5 units. And really that comes from just the Pythagorean theorem, x squared plus y squared equals r squared when we did our translation. The other two are a sine theta and a cosine theta. Notice how close this is to a polar rose. Remember, in a polar rose, it would have been a sine of b theta, where b determined how many petals you had. Well, if you let b be 1 and 1 is odd, you're going to see one distinct petal. Also, because it's odd, you're going to get the whole circle by only going 180 degrees around, because technically there are two petals, but we only see one distinct one. So to get the whole circle, you're just going to go 180 degrees. Now, the key to graphing polar circles then is to look what function you have. The sine function we're going to associate with the y direction, whereas cosine we want to associate with the x. So we want to think y here, think along the y-axis if this were on like an xy plane, and think along the x-axis. And the coefficient A actually represents the diameter. Same thing with this A right there. So if I think about 4 sine of theta, think about sine of 0 is 0. So we know it's starting, right? It's starting at the origin. So I'm going to go ahead and put a little star right there. Like it starts there. Goes in a counterclockwise direction, and then I know that, I'll put this darker red, I know that the diameter is 4, and it's going to be on the positive y-axis, so 1, 2, 3, 4. So I'm going to create a circle like that. And again, knowing that the diameter is equal to a distance of 4, and it goes in this direction. So I want to go ahead and arrow the counterclockwise direction. Now, how do I know it's only 180 degrees to get the whole image? Well, you could do a table of values, right? You could let theta be 0. We know the radius is 0. You could let theta be 90 degrees. And since the sine of 90 is 1 and 1 times 4 is 4. And then if you go back to 180, you're back to 0. You could do 270 and you get negative 4, but 270 negative 4 is right back up there. Right. So, and again, why did I pick 90? Because just like in a polar rose, it's 90 divided by that coefficient B. So 90 over 1 means that every 90 degrees, we're going to reach our equilibrium highs and our lows. Okay. So next, -3 cosine. So for cosine, I'm thinking along the x-axis. And because it's negative, it's going to be on the negative x side. And again, if you wanted to do a table of values, you're going to see, like when theta is 0, well, cosine of 0 is 1, 1 times 3 is -3, so it's actually going to start on the left side, right? We saw that that when it's negative, it begins on the left, 1, 2, 3. And then we just draw in a counterclockwise direction, so it would come down here, tangent right there at the origin, and back. And again, draw those arrows so we know the direction that it goes. And the radius was -3 at 90 degrees, since the cosine of 90 is 0. And then at 180, well, the cosine of 180 is -1 times that -3 would be +3. So we're right back at the start. Okay. R equals 4. I guess I jumped down to that one. So R equals 4. So you might not know or think that, oh, where does this going to start? Because there's no theta. It's always 4. 1, 2, 3, 4. And so technically that's true. It's always 4. But you have to start somewhere in a table of values. So you'd start at 0. And since it's a positive 4, I would know that positive 4 distance is on the right. Had this been R equals negative 4, even though the image would have been the same after we graphed, it would have started on the left. So the negative does matter. But here it's a positive 4, so it starts on the right, and we just go in a counterclockwise direction. Every theta that you would graph has a constant radius, I should say, of 4. Okay, and then negative 6 sine theta. So we can we're thinking negative y-axis since it's negative sine. We want to associate that, and we're going to find out in class there are other graphs that association with sine being y and cosine being x is really, really important. Diameter of negative 6, so 1, 2, 3, 4, 5, 6. So I know it's going to head down there. And again, sine of 0 is 0. So we're going to start at the origin, and then we're going to go in a counterclockwise direction. So we go out to here and make our best circle, going to the left, because that in this direction is counterclockwise. Okay, so yeah, circles, like I said, circles really, other than like this one, circles are just a one-petaled rose. So because it's an odd petal, you only need 180 degrees to see that one distinct, that one distinct circle or that loop. Now, example 9, certainly pause the video and come up with these and then check it, right? Create 3 different equations for circles that each have a radius of 8. So I guess the most basic could be R equals 8, or you could say R equals negative 8, because remember, where would R equals negative 8 start? It would start on the left and then go in a counterclockwise direction, so it would still have a radius of 8. Now, you might initially say like, oh, let's do R equals 8 cosine theta, but we are, yeah. Oh, no, that's right. R equals 8 cosine theta, because that you might think that, oh, that I need an 8 there, but if I do R equals 8 cosine theta, I know those things. Remember that 8 is the diameter, and so that meant the radius would only have been 4. Hopefully you didn't think that. Maybe I confused you by thinking what you were going to think like. I don't know. So let's make that a 16, because then if the diameter is 16, you have a radius of 8. You could easily also say R equals 16 sine of theta. You could also say any of the negatives, simply because it just starts in a different location, but would still have the same radius. Okay, and then same thing I would say with the next example. Like maybe pause the video. I noticed I did a terrible job of counting example 9 and then back to 8. But come up with an equation. So maybe pause this and then see see if you get the answer. So if you want to hit pause. Okay, and then maybe you did, and you check your answer. So let's see, 1, 2, 3, 4, 5, 6, 7. So the diameter is 7. It's in the negative sine direction. So I would say negative 7 sine of theta. Now this starts, I like that starts in the middle, so I know it's a sine function. It's a rose. The petals are 1, 2, 3, 4 long, and there are 5 of them. So 4 sine of 5 theta would give us that graph. Okay, this one is a radius of 2, and notice it's starting to the right. So I'd say positive 2. Had it started there, it'd be negative 2. And then this is cosine, and there are 3 petals, a length of 1, 2, 3, 4, 5, 6. And how did I know it was cosine? Because it didn't start. It didn't start at the origin. It started on the x-axis. And notice it's starting on the left. So I want my initial radius to be a negative 6. So R equals negative 6 cosine of 3 theta. So, after I know, we had a series of videos here, and my hope is that you feel comfortable enough and familiar enough with polar roses and circles, which are sort of like just a very general one-petaled rose, other than if you just have an R equals a constant.